Next up, Mr. Chris Keegan. He's going to be speaking to us regarding timber bridge repairs and preservation. Please welcome Chris again.
You're in luck, because this is actually a presentation I did 8 years ago. And because we had somebody drop out, I volunteered to just jump in. What I thought was interesting about this back then is I gave it, I wasn't sure how much interest there'd be, because people were getting rid of their timber bridges. Well, I gave it, and Louisiana and Georgia have thousands of timber bridges. And I was really amazed at that. So anyways, it was really well received, and I had a lot of questions at the end. One of the biggest problems we have with timber bridges is with the deck. Eventually they're going to fail. And when they fail, they're very difficult to replace. We've tried all sorts of things, steel plate them, all sorts of things. And we build ours pretty well. What they do is they 3x4-inch laminated, nailed to each other when they're originally built, all the way across. So it's like a solid mass up there. But when they go, they go. And underneath, we don't nail our decks to the stringers. There's a nailing strip in there. Actually, everything is bolted together, a bolting strip through there. So we're not actually getting into the stringers. So to open that up, the creosote to early failure. But once these decks go, there's really not a whole lot timber decks you can do with them. Get a whole lot of complaints from the public and the roadway maintenance people. Concrete decks, some of ours have concrete decks, and these seem to have worked pretty well. Timber decks with the bolting strips are better than nailing to stringers. Bolting strips require tightening as the deck ages, because they do loosen up about every 10 years or as needed. A lot of these timber decks need running boards or overlays on them, something to keep it from being worn away. Timber bridge repairs. Easiest, simplest thing we do is we get splits. If you know a timber bridge, you have the cap. The cap, there's a rod through the cap into the top of the pile. And oftentimes that causes a split. And the repair for that is we just bind it up with a plate and bolting. Cap repair. One of the most difficult parts about that is access, if you're going to go to replace the cap. One is to build temporary bents under the bridge to jack up the bridge. Trouble is, it doesn't work over water. It's difficult on slopes, difficult on very high bridges. It's time consuming, but it does have minimum traffic impact. The alternate to temporary bents are jacking beams on the road deck, jacking blocks chained to piles, and jacking blocks clamped to piles. The problem with jacking beam on the road deck is you're going to have to stop traffic while you do it. Jacking blocks chained to piles, they have a tendency to dig into the piles, so you're actually causing damage to the bridge. And the third one is jacking blocks clamped to piles. This is an example of our crew in Washington. Those are aluminum clamps that they developed in-house and bolt together. It clamps tightly to the pile. And with that, they can jack the cap up off the piles, or they can turn it, and they can actually lift the deck up off the cap. So it works both ways. Cap replacement, number one, you can replace cap in kind. Difficult to do these days because we can't buy creosote-treated caps anymore, and that is really the best you can do. We can't get old-growth timber, and that's what the old ones were made of, very tight grain. Take a heck of a load without being squished. Cap replacement with that, if you can get a 12 by 12 cap in there, it's really a lower cost than some other things. It's difficult to obtain permit for creosote. New timber is not as good as the old growth. Requires traffic control and temporary road closures when you take the old cap out, put the new one in. And requires a crane of some sort. You can replace it with a steel beam instead, but may be difficult to match the existing beam size. Costs more than replacing kind, requires traffic control, again, and temporary road closures. What we came up in Washington was steel cladding. And the reason why we did this is way back when I first started with the Department of Transportation in 1978, I think we had about 126 timber bridges. I was told at the time not to worry about the timber bridges because within 10 years they'd all be gone. When I retired last year, we still had 96. So they didn't go away, they're still there, and our bridge program manager said, Chris, You got to keep these things going. We just can't afford to replace them. That was what I had about 10 years before, was trying to keep these things going. So here's an example of the bridge cladding around the thing, around the cap. The cap has pretty much failed. It's down to about 1.5 inch hollow square tube at this point. And what the crews do is they measure up the cap and they build these things, and then they have them galvanized. They weigh about 150 pounds per section that they build, so that 2 people can lift them and put them in place. Again, with that jacking system that they have, they can either lift the deck off to put part of it in place, or they can lift the cap off the pile to squeeze this thing in between the cap and the pile. And they just put these things on, they bolt them together, and this is designed such as the cap in between can rot away, and this will hold the entire force of the bridge. Here's another look at it. And it's a nice looking repair. I tell you, it looks better than the old black creosote treated pile. We have one bridge. I think 5 of the 7 caps have been replaced. And if we keep working on it, with the piles being changed to steel, it's going to be a steel bridge instead of a timber bridge. Here's one a little farther up. We also used jacking boxes, and that was to restore the amount of force into the pile from the cap. The jacking box, again, the crews build them. You put your jack in there. You bring it up to 10 or 15 tons, whatever the force used to be, to restore the amount of pressure into the pile. Here's where I learned about the difference between old growth and new growth timber. This was a bridge that was washed away back in 1949, and it was replaced with, I think they called military beams, because in 1949 you could get a lot of Army surplus stuff. So the bridge was made with these Army surplus beams. They were readily available, but the structure underneath was timber, because again, it's Pacific Northwest. Timber was easy to come by, a lot of creosote treated stuff, all old growth timber, really fine grained material. Bent there was deteriorating. Everything was either red tagged or we call yellow tagged, one way or the other. So I decided, let's get rid of it all and replace it in kind with treated timber. And I was actually able to get the members cut and treated, creosote treated, up in British Columbia at the time. And the crew went in, and we spent quite a bit of time jacking this thing up, take the load off, put all new members in, let the load back on the bridge, on the bent. 6 months later, when they went in to inspect it, all the stuff, everything we put in there had crushed. The old growth versus the new stuff with a wider spacing for the thing, and so we ended up going back and replacing everything with steel, all galvanized. It'll last a long time. Here's the very last timber truss bridge we have. One of the truss legs was rotten, and we had to replace it. And we have, again, Army surplus. This is an Old Bailey bridge. We used that to take the load off the members so we could remove the existing rotten leg of the bridge. Took that thing out. Here it is with the crane swinging it out. Here it is up on the deck. You can tell it was pretty rotten. So what do we put in place? This is a steel box. It was cut, measured, put in place by the crew, and painted black so it kind of match what's there. And here's one of the connections. A timber pile replacement. Here's one where you just use 12-inch diameter piles. Put those in place, and we make the connection to what's left of the timber in the ground with concrete with rebar in place. If you ever try to replace a 12 by 8 or 6 by 18 stringer with another 6 by 18 stringer under a bridge, it's really difficult. They just don't fit. So instead, we had to been replacing stringers with steel, and you can use a smaller section of steel than you would the timber, and they're a lot easier to put in place. Now, what about prevention? This is the guide for in-place treatment of wood in historic, covered, and modern bridges. And this is produced by the U.S. Department of Agriculture, Department of Transportation, and the U.S. Forest Service. It's available if you want to. Copy this down, Guide for In-Place Treatment of wood in historic, covered, and modern bridges. Tells you all the stuff and what to use. I looked this thing up after I got a call from Oregon. Just asked me one simple question. Do you use borate on your timber bridges? I didn't reply right away because I had no clue what he meant. But once I looked it up, borate is what, if you have pest control, take care of your carpenter ants, if you got termites, whatever else, it's what's used in the industry. Also, utility companies, to make their utility poles last longer, they use borate. It comes in a powder, it comes in rods, and it comes in kind of a gooey paste also. And this shows what they do on a utility pole to prevent rot. Basically, clean it up, put the goo on, wrap it in plastic, and then you can put the dirt back in. Borate rods, they're a low-cost means to prevent rot by killing the fungus that causes rot. It's in use by the log home industry, railroads, and utility companies. It's activated at 25% moisture content, which is the same as when fungus activates. Protection lasts about 10 years until it dissolves, and it's available at your neighborhood paint store. Again, this is from the same USDA pamphlet showing how to do everything. This is on what would have been a pile in the end, and they're using a powder in this one, but you can also use the borate rods. This is up in the cap. This is in what is the pile or a post. Here's what ours kind of look like. Here's one of the crew members putting them in place. Get up there with a drill. We use the 7/8 inch rods. They're about 4 inches long. You can fit about 2 of those in each of the holes. The holes are about 6 to 8 inches apart. You look for where the rot area is and make sure you go well beyond it on both sides. Put in the borate. It should give you protection from the rot increasing for, again, about 10 years. These are the rods, if you can see them in there. It's just a 4-inch borate just compressed into a rod. The other important thing is to track the usage, because the inspectors want to know which ones you put it in. There are 2 things you can do once you put them in. What our crew did at the beginning is just get a 7/8 inch dowel, cut them pieces, and pop them in there like a cork. But the industry that makes the borate also has these little plastic things you can put on and just etch in the date you put it in, which is good for the inspectors. And the inspectors can look at that date and say, okay, it's been in there for 7 years. We better check it and see how much of this rod is still left in place. And then you just pull that cap, put another rod in there and put the cap back in. And they can do it during the inspecting, just carry extra material with them. And that's it. I think I went through a little fast on this one.
Any questions? Okay. Oh, there's one.
We use Doug fir hemlock everywhere. These were all built in the 30s up into the early 50s. We had old growth timber, very few knots, really, really nice material. And the creosote on these things is thick. I mean, they really soaked them for a while. And it goes in there about 1.5 to 2 inches into the wood. Good penetration. Like I said, we've had them since the 30s, and the bridges are still there. They require some maintenance now, but they're good.
So when you replace some of the energy, do anything special with that?
Like the truss member, it's a compression member that we replaced. Not sure if it's fracture critical though, because you're not really changing. The loading stays pretty constant across that thing. So I don't think so. It's actually stronger than the timber that was there before. Our only really concern was the connections at both ends, making sure those were good. And this was all we had. Went through our bridge office. We had designers work on it, to work with the crews. So what is there is going to be there longer than the rest of the bridge. Now, if this was a stringer or something, or a beam, like a 2-beam bridge we replaced or something with steel, then yeah, it could become fracture critical.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.